Hi everyone. I am out ill today, but we will continue our discussion about the standard normal distribution. Make sure that you have your z-chart available with you so that you can look up z-scores in your table to find the cumulative area or probabilities. The cumulative area is close to 0 for z-scores close to negative 3.49. So remember, a z-score tells you the number of standard deviations you are away from the mean. So if we look at this standard normal plot, the mean is 0 standard deviations away from itself. This would be 1 standard deviation above the mean, 2 standard deviations above the mean, 3 standard deviations above the mean. 1 below, 2 standard deviations below the mean, and 3 standard deviations below the mean. What they're saying is that at about 3.5 standard deviations, the area to the left of 3.5 standard deviations, so the cumulative area over here in that little tail, is approximately 0. So what we're saying is that the probability of a data value being more than 3.5 standard deviations below the mean is likely 0. It's almost impossible for a normally distributed data set to have a data point more than 3.5 standard deviations below the mean. Now, one other thing we can talk about here is that the cumulative area increases as the z-scores increase. So the cumulative area to the right, when you get beyond 3.5 standard deviations, right? So if we're at positive 3.5 standard deviations, a z-score of 3.5 is 3.5 standard deviations above the mean. That cumulative area would be close to 100, right? Because if the plot is symmetric and the area to the left of 3.5 standard deviations below the mean is 0, then we would expect this area to the right of 3.5 or to the right of 3.49 standard deviations would be approximately 0 as well. So if the area to the right of a z-score of 3.49 is 0, then the area to the left of it would be close to 100% or 1.00 as a decimal. The cumulative area for z equals 0 is 0.5000, and that is because the z-score of 0 splits the symmetric distribution in half, and so we would expect the area to the left of the mean to be 50% or a probability of 0.50, and the area to the right of a z-score of 0 would also be 0.50. I mentioned this on the last slide, that the area to the right of 3.49, so when you're approximately 3.5 standard deviations above the mean, the area to the left of that would be close to 1, and the area to the right of it would be 0, right? So this little tail down here would have an area of 0 approximately. Now, what we're going to do is find the cumulative area that corresponds to each z-score. We did some of this at the end of class yesterday. Now, this is the z-chart from the book. Obviously, they've ripped it up to kind of get to the z-score that they want. I'm going to go ahead and look at our z-chart, and we're looking up a z-score of 1.15. Okay, we are looking for the area, the cumulative area to the left of a z-score of 1.15. So if you take out your z-chart that I gave you yesterday, right, I'm just going to draw a quick little distribution, a bell curve, right? A z-score of 0 is right at the mean. Here's 1 standard deviation above, here's 2 standard deviations above, here's 3 standard deviations above. we want to know the area to the left of a z-score of 1.15. So let's just label 1.15 here, and we're looking for the total area or cumulative area to the left of that. Well, we know that it's going to be greater than 50% because the area to the left of 0, like if I draw a line, a symmetry line here at 0, we know that this is 0.50. So it's our job to add 2.50, or 50%, this area here in this green shaded region from 0 to 1.15. Right, this z-score right here is 1.15, that blue boundary line there. And so what we're going to do is try to figure out what the area, the cumulative area to the left is. So I'm going to look up 1.15. So here's a z-score of 1.1. And we want a hundredths place of 5. And that happens up here, 0.05. So if you add 1.1 plus 0.05, right? 1.1 plus 0.05 is 1.05. So what I'm going to do in my table is I'm going to go across horizontally in this row until I get to a hundredths place of 0.05. And if I go down vertically down the column of 0.05, this will be my cumulative area to the left of 1.15 on our distribution. So the total area, the total all the way to the left of 1.15 would equal 0.8749. Now we could also ask questions, this is our answer, but we could also ask questions like, what was the area just in that one region from 0 to 1.15? So we could break it up into pieces here. We know that 0.50 plus that red shaded region from 0 to 1.15 has to total 0.8749. And what we could do is we could create an algebraic equation and subtract 0.50, and then the area, the cumulative area in the red region from 0 to 1.15 would be 0.3749. Okay, so the probability of randomly selecting someone in that region that is between 0 standard deviations above the mean and 1.15 standard deviations above the mean is about 37.49%. 37.49% of the area is between 0 and 1.15 standard deviations if our distribution is normal, if it's symmetric, if it's not skewed. So I just added that little piece on here that we found the area to the left of the z-score using the table, and then I just extended the question a little bit to see if we could figure out what the area was from 0 to 1.15. Okay, we are going to do the same thing. We're just learning how to use this standard normal table. We want to find the cumulative area, the total area that corresponds to a z-score of negative 0.24. So when we talk about cumulative area, we're talking about the area to the left of negative 0.24. All right, so now I'm looking at my z-chart again, my standard normal cumulative probabilities here, my z-chart. And I want to look up a z-score of negative 0.24. This is our z-score. So we're going to look up on the side here, negative 0.2. Here's a z-score of negative 0.2. And then I need a hundredths place of 4. So here is 0.04, negative 0.2, and negative 0.04 is negative 0.24. So I'm going to go across the column at negative 0.2. I'm going to come down the column here. So across the row at negative 0.2, down the column at 0.04. and we can see that the cumulative area to the left of a z-score of negative 0.24 is 40.52. 0.4052 is 40.52%. Now to put this in perspective on a distribution, I'm going to draw my bell curve here. And here's a z-score of 0. Here's a z-score of negative 1. Here's a z-score of negative 2. Here's a z-score of negative 3. Negative 0.24 is right here. We know that the area to the left of 0 is 0.50, right? If I had drawn my boundary line here, the area to the left of 0 is 0.50 or 50%. So we know that the area to the left of negative 0.24 is going to be slightly less than 0.50. So what we found is that the area in that region, the cumulative area from a z-score of negative 0.24 to the left is 0.4052. 0.4052. So that means 40.52% of the area under the curve is to the left of a z-score of negative 0.24. All right, so I've been finding areas under the standard curve. I've been taking the z-score they give me and drawing a diagram, drawing a normal curve, and then labeling where our z-score is at, and then shading to the left of that to show the area to the left of that specific z-score. So this is what we've been doing already. Sketch the standard normal curve and shade the appropriate area under the curve. So shade to the left if they're asking for the cumulative area. If they're asking for the area to the right of it, we would take 1 minus the area to the left. So find the area by following the directions for each case shown. To find the area to the left of the z-score, find the area that corresponds to z in the standard normal table. You look up your z-score in the table. Whatever decimal you get is your area to the left of that z-score. Now, the area to the right of that, right? The area to the right of that in this white region, the total area under the curve is 1. So I could say 0.8907 is the area to the left of a z-score of 1.23. So if you looked up 1.23 in your z-score table, in your standard normal table, the corresponding area would be 0.8907. Now, if I wanted to know the area to the right of that, in that white region, right, where I'm putting these question marks, I know that the area in blue plus the question mark has to total up to 1. The area to the left of a z-score plus the area to the right of the z-score has to total up to 100%, or 1 as a decimal. So if I wanted to find the area to the right of a z-score of 1.23, I would solve that algebraic equation for the question mark, the unknown value, by subtracting 0.8907 from both sides. So 1 minus 0.8907, if I subtract those, 1 minus 0.8907 is 0.1093. 0.1093 would be the area to the right of a z-score of 1.23. Notice that on this slide, that is exactly what they did. The next step was to find the area to the right, or the next follow-up question was to find the area to the right of 1.23. So they subtracted the area to the left of 1.23 from 1. Right? They subtracted 0.8907 from 1 to get an area of 0.1093. Okay, the next type of question they're going to ask is to find the area in between two z-scores. Okay, so we know the total area under the curve is 1. What I can do is I can start out by finding the area to the left of a z-score of negative 0.75. So if I look up negative 0.75 in my z-score table, I should get, if you look that up in your table, you should get an area of 0.2266. If you look up the area to the right, or sorry, to the left of 1.23, right? So if you find the area to the left here, this red shaded region, look up a z-score of 1.23 in the table. And if you look up the z-score of 1.23, we already looked that up previously, that's 0.8907. So the red shaded region has an area of 0.8907. The yellow shaded region had an area of 0.2266, right? What we could do is we could subtract them from one another. I only want the blue region, and the yellow and the red region overlap, right? The yellow and the red region overlap. Therefore, if I take the area to the left of 1.23 and subtract off the area to the left of negative 0.75, so I'm going to show that. If I take that away, if I subtract it, that means I'm going to be removing that yellow region. We end up with the area in the blue shaded region, right? So if I took my red shaded region area and subtracted off the area in the yellow shaded region, we end up with the area here in blue. So when we subtract those two, we get an area of 0.6641. So the cumulative area between a z-score of negative 0.75 and 1.23 is 0.6641. Now, what you could have done is found the area. Another method we could have used to find the same answer here is we could have found the area to the right of 1.23, which I believe was 0.1043. Excuse me, that was 93. And the area to the left of a z-score, this area right here in brown is 0.2266. So if you took 1, the total area under the curve, and subtracted off the tan shaded regions of 0.2266 and 0.1093, that should give you the same answer here of 0.6641. Okay, our last few slides here, they want us to find the area under the standard normal curve to the left of a z-score of negative 0.99. So I'm going to draw my bell curve. Here's a z-score of 0. Here's a z-score of 1. Here's a z-score of 2, 3, negative 1, negative 2, negative 3. And a negative 0.99 would be right about here. So we're looking for the area in this shaded region to the left. The cumulative area to the left of a z-score of negative 0.99. So what I'll do is I'll look up a z-score of negative 0.99 in my table and find that area. All right, so if we look up a z-score of negative 0.99, here is negative 0.9 to the nearest tenth. Now I need a 100 spot of 0.9 or 0.09 right here. So if I take a 9 in my 100 spot, I get negative 0.9 plus a negative 0.09, and that gives me negative 0.99. So if I follow the row where negative 0.9 is all the way down to the end where our hundredths place of 0.9 or 0.09 is, right? A 9 in the hundredths place. Okay, that cumulative area to the left is 0.1611. So the area, the cumulative area to the left of a z-score of negative 0.99 is 0.1611. All right, in the next example, we're going to find the area under the curve, the standard normal curve to the right of a z-score of 1.06. So I'll draw my normal curve, my bell-shaped curve. Here's our z-score of 0, our z-score of 1, a z-score of 2, and a z-score of 3. We want to know the area to the right of 1.06. So this area to the right of a z-score of 1.06. So remember that the z-score table, the standard normal table, gives us the area to the left of all the z-scores that are in that table. So when I look up 1.06 in the table, it's going to give me the cumulative area to the left of 1.06. What we'll do then, we'll take that area to the left of 1.06 plus the area to the right of 1.06 is equal to 1. Looking up a z-score of 1.06, we're going to start at 1.0, which is right here, and then we're going to go out to 600. So 1.0 plus 0.06, we're going to go out to the 600th spot and go to the right here and then come down the column where 0.06 is, and this area right here represents the area to the left of a z-score of 1.06. So 85.54% of the area is to the left of 1.06 on the standard normal curve. Okay, so remember, area to the left plus area to the right of that z-score has to total up to 1. We know the area to the left is 0.8554. We want to know the area to the right, and then that equals 1. So we can take the area to the right is equal to 1 minus 0.8554, which is a total of 0.1446. 0.1446. So the area to the right of a z-score of 1.06 is 0.1446, or that represents 14.46% of the total area under the curve. All right, this time we are going to find the area under the standard normal curve between these two values. All right, so we'll draw our bell curve, our standard normal curve the best we can. And we want to go from a z-score of negative 1.5, which is right about here, to a z-score of positive 1.25. So from here to here. Okay, so we're looking to find this area right in here. So when I am looking up a z-score of negative 1.5, it's going to tell me the area to the left of that z-score. So if I look up negative 1.5 in the table, so the area to the left of z equaling negative 1.5. When I look that up in my table, I get 0.0668. Now, if I look up a z-score of 1.25, right, 1.25, it's going to give me the area from 1.25 and below. Right, so it's going to give me this area all the way from 1.25 all the way down to the end, to the very far end of the tail. So if I look that up, that is 0.8944, the area to the left of a z-score of 1.25. Now what I want is the area shaded in yellow. So if I take off, right, the area that we found right here to the left of negative 1.5, if I took that away, if I erase that off, we're taking away how much of the area? Right, that area that we just erased was 0.0668. So the area in between negative 1.5 and positive 1.25 is 0.8944. 0.8944 minus the area we erased was 0.0668. And if I subtract those two values, okay, so we are just going to summarize the lesson here. What we did in lesson 5.1 is we interpreted graphs of normal probability distributions, and we also were able to find the areas under the standard normal curve. I have posted your assignment. The one we started yesterday in class is on Schoology in the materials section, and it's dated with yesterday's date of 4/11.